Welcome to B.A.M Physics. If your mind isn't exploded by the end of this, we didn't do our jobs. Alright, so here's the question. A 0.50 gram insect rests on a compact disc 4 centimeters from the center. The disc has a minimum rate of rotation of 3.5 Hz and a maximum rate of rotation of 8.0 Hz. We know that the mass of the insect is 0.50 grams, which converts to 0.0005 kilograms, and that it rests 0.04 meters from the center of the compact disc. We can sub in these values along with the minimum frequency of 3.5 Hz into the formula Fc equals 4 pi squared mRf squared in order to find the minimum acceleration. The maximum acceleration can be calculated by using the same formula, but by substituting in 8.0 Hz as the frequency. This gives us a minimum acceleration of 19.3 meters per second squared and a maximum acceleration of 1.01 by 10 to the 2 meters per second squared. Next, we need to find the minimum value of coefficient of static friction that will prevent the insect from slipping off the disc at the slowest rate. We first start by drawing a free body diagram of the insect on the disc. Next, we need to find the value of the force of static friction using the formula Fs equals Fc and the minimum acceleration of 19.3 meters per second squared. This gives us a value of 19.65 by 10 to the negative 3 newtons for the value of force of static friction. Lastly, we can set the force of static friction equal to or less than the coefficient of static friction times the force normal and isolate for the coefficient of static friction using our previously calculated value for the force of static friction and the force of gravity to find that the coefficient of static friction is equal to 2. Therefore, the minimum acceleration is equal to 9.3 meters per second squared. The maximum acceleration is equal to 1.01 by 10 to the 2 meters per second squared. And the minimum value of the coefficient of static friction required to keep the insect on the disc is 2.0.